in this question, you're supposed to find the tension in the string T1 and T2. And likewise, you should know that it's an action-reaction pair. But of course, T2 will, since it's dragging more mass compared to T1, so T2 will have a higher magnitude compared to T1. Now, similarly, we will consider it as a whole system. Okay, and there's a force of 90 Newton pulling to the right, and the total mass is the sum of the 3 boxes, so it will be 3 plus 2 plus 1, so total mass will be 6 kg, and the total frictional force, you're going to sum all of them up, it will be 60 Newton to the left. So you consider it as a whole system, and I'm going to apply F equals to ma. So the resultant force acting on this whole system will be 90 minus 60 is equals to the total mass, which is 6 kg, times the acceleration. So the acceleration of the whole system is 5.0 meter per second square. Now, so to solve for T1 first, I will select the block P because it has the least number of forces acting on P. So let's draw the free body diagram for P, which is 1 kg, and the only force acting is T1, and there's, of course, do not forget the frictional force of 10 Newton. So these are the forces acting on P, and there's only one unknown T1, and I'll be able to solve it. So applying F equals to ma, the resultant force acting on P will be T1 minus 10 is equals to the mass of P, which is 1 kg, times the acceleration 5, and I'll be able to solve that. T1 will be equals to 15 Newton. So I've solved for T1, and now to solve for T2, I will be using the free body diagram of Q. So this is Q, and we list down all the forces acting, which is T2, and this will be my T1, which we found already, 15 Newton, and the frictional force of 20 Newton. So I'm going to apply my F equals to ma, where F is the resultant force, so it will be T2 minus away T1, which is 15, minus away the frictional force 20, and the mass of Q is 2 kg times the acceleration, which is 5. So from here we can solve, and we can find T2, which is equals to 45 Newton. Alternatively, if you want to use block R to find T2, you can also. So this will be the free body diagram of R, where the forces acting will be the 90 Newton, T2 to the left, and the frictional force of 30. So once again, I'll use F equals to ma, and the resultant force will be 90 minus away T2 minus away 30 is equals to the mass of R, which is 3 kg, times the acceleration 5. So you'll get the same answer. T2 will be 45 Newton also. So that's how you solve this question.